Hello, my name is Stanley, and for today I will be showing you a demo of a two-way tape automata emulator. We'll be having three test cases. The first one is where the number of A's is 4 and the number of B's is 3. And then the next test cases will be the number of A's modulo 5 is 2 and the number of B's modulo 2 is 0, or the number of B's is even. And then the last one will be the number of A's are odd and the number of B's is even. So here are the program for A. So let's just change this into A4 and B3, and then we will load the program. After we load the program, next thing we want to do is to try it. Let's say empty string should reject because it should accept only if A is 4 and B is 3. So A is 4, B is 3, then it will accept. Otherwise, it will reject. Maybe, and then let's say A, B, B, A, B. This is 4 A's and 3 B's. It will accept. And then B, 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 A. This should accept as well. And then the rest, for the rest, it will reject them. Yeah. So that's for the first test cases. For this test case, then for the next test case, the next test case will be where A modulo 2 is odd and B modulo where A modulo 2 is modulo 5 is equal to 2 and B modulo 2 is equal to 0, or B is even. So A mod 5 2 and B even. So I run this, and these are the program, the states, and the symbols. So if we say 5 A's and 4 B's, they should reject because 5 modulo 5 is 0. And 2 A's, 4 B's, they should accept. 2 A's only also will accept because the number of B's is still even. And then 7 B, 7 A's and 2 B's, they should accept. And then same thing if I just randomly assign it. Let's say this is 1, 2, 3, 4, 5, 6, 7. That's 7A and 1, 2, 3, 4, 5, 6, 7 A's and 6 B's. It will still accept because both fulfills the condition. And if I put some random characters to say that it's invalid, so you cannot put random characters aside from A's and B's, and then yeah, it those that's the second test case where number of A's modulo 5 should be equal to 2 and the number of B's should be even. For the next test case, I will just make it, I will type it manually here. So let me bring up this one. So I'll just make this empty so that we can input things manually. So let's say we have 7 number of states and we have A to B1 sharp 3, A1, B2 sharp 6. You have left A3, B3 sharp 4. We have right A4, B5, B5, and sharp 6. Left right A5, B4, B4, and sharp 7. Then this one is the accepting state, this one is the reject state. So these are the states and the symbols. So these are a number of whether the number of A's are odd or the number of B's are even. So let's say I put empty string, it should accept because the number of B's is even. And if I put here only one A's, it should still accept. But if I put A, B, it will still accept because A is odd. But if I put A, B, it should reject. If I because like A is even and B is odd, which is the other way around. And if I put, let's say AB, this means A is even and B is even, so it should accept. Yeah, and then let's say B, A, B, B, A is odd, B is even. This should accept, and then B, both are evens. It should still accept, and these are, and that concludes the test cases that we have. So I will now be explaining the approach that I took for the Two-Way Tape Automata. First, I made a class called TW Tape Automata, which has an attribute of self.q, which is the set of states, and then self.s. This will be the set of symbols, and there's a self.start for the for which one is the starting state, and then the accepting state, and then the reject state, and then there's a debug here for in case for debugging. The start state will have one of the values in this list, and then the accept and reject will be just a an index, like an index of the state, like which like the state number in here, like which state number is this basically, and then um, we have an at state. At state will have accept an index. This will be a string of number. It actually can be, it can be a string or it can be a number, but I choose to make it just a string since there's not much different when if you use number instead, so that I won't have to um, do extra to convert it to int. And then the direction by default it's none. It will be none if it's, let's say, an accepting state or reject state, or held the held state. It will be none. And then for the transitions, this will be the list of tuples where uh, it will be like this: an array of a list of A2, B1, sharp 3, and both each of these will be a string, like this: string, string, string. And maybe for it to be clearer, I'll enable the debug, and let's try to load the last program we have, the one A odd or B even. And then if we try to load it, we can see in here that this how state.self.q will look like, and this is how each state will look like. It has a direction, it has an index, apparently it's an integer, and then this one is string, yeah, this one is string, this one is an integer, yeah, I forgot this one is an integer, this one is a string, yeah. So, and then this is the stuff.s, and then what happens in here after this one, uh, this part will just say for each next, let's say for this one, the first state, so this will be saying when it sees a sharp, we go to state 3. So the next in here basically has a key, where the key is this the symbols it sees, and the value is the next state it should go to in the form of string. And then uh, this part of the code will just add the um, the symbols that it encounters, which is D0, which is this part, the A, B sharp, and yeah, and it will make sure that it's unique. Then self.geopen state, just adding the list to the list of state, and then set accept. This will just set the accept into the index, and then for the parse part, for the parsing part, if I see an accept, I will just say at state, and then this will be the index of the state. Then this will be the direction and the transitions. And then I will set, this will be where I set the accepting state. same as this one, whereas the reject state goes the same way. And then for the input string, I will split it by space. So this will be split by space. So you will see an array of write A to B1 and sharp 3. And then direction will be the input string 0, which is this one. So basically the state that being passed in here is actually this part. Go to the end. This part go to the end without the number. And then for I in this going forward, from the index 1 going forward, it will first remove the um, new line character, the backslash n. That's why we have this. That's why we have this. And then we're gonna split this by um, comma. So we'll have a t split, and then this one we'll be having like a's and b's. So that's where we get this one. T0 dot strip will get the a's, and T1 strip will get the b's, and then just add the state going back here. And after that, this is to check if the input string has the same characters in the symbols. And then lastly, the run TWA, basically this will start at index 1. Always start at index 1, which is if I have a string like this, let's say I have a string like this, index 1 will be this one. So it will set it to start at this point. And then it will set the initial state, and then if we see that state index is equal to the accepting state, then it will just print accept and break. Same thing for the rejecting state. Current will take the current character it's pointing to right now, and the next state, this is just for debugging, the next state will go state dot next dot current. So state dot next, let's say the current character is sharp, so it will get the next state, which is at index 3, for example. And then the next state will just be self q, and then convert this to int because this is a string, and then -1 since the index of the state does not start from 0. And then if the next state's direction is right, increment the index of the string, and then else decrement it and initialize through TWA, just setting the start state to self, the first element in queue. And then this is where we display the last this part, states and stimulus. And then yeah, I think that's all. And then on this part, this is where we'll be getting the input continuously until the user type exit. Yeah, okay, I think that's all for today's demo. Thank you very much.